1, 2, 3, and 4 Roman numerals. All right. So a ball is thrown in the air at 40 feet per second. Its height in feet after t seconds is given by y equals 40t minus 16t squared. For you physics people, gravity is 32 divided by 2. It is a parabolic function. Find the average velocity. Now this is where we got to get to this. Remember we talked about this. When I get pulled over going 40 miles an hour, I like to tell the cop, oh, I was going 0, now I'm going 40. I must have an average of 20. No, right? Well, they want the instantaneous, but this time they want the average velocity. The average velocity, guys, is a secant line. The instantaneous is a tangent. So it says find the average velocity for the period beginning when time equals 2 and lasting 0.5 seconds. So if it starts at 2 and lasts 0.5, when's it end? 2.5. Guys, this is t from 2 to t 2.5.
So it's t equal 2.5.
Yep. For the,
oh, so you
and then
the wrong number.
And then the next one is t starts at 2 and lasts 0.1 seconds.
Oh, that's
2.1. Then t goes from 2 to 2.05. Yep. But listen, that's going to be
the wrong number.
This is going to be a ton of work unless we fix it. So everybody, I want you to think of it this way. Everybody, it's a parabola. We have the position y is defined as 40t minus 16t squared. A real quick graph, really rough, super rough. You guys see, it goes through the origin 0, 0. At time 0, it's at position 0. We throw a ball up, unless you're Superman, and you throw it to the moon, what happens? It goes up, and it comes down. There's our parabola, right? And this is the y, and this is the t. And I don't know where 2 is on this graph, but I'm going to exaggerate. I love exaggeration anyway. I'm going to put 2 right here. You guys agree? And what's my position? How about y of 2? Instead of, there's a value there, I can figure it out, but I'm going to call it y of 2. And I want a secant line that lasts 0.5, and then I want 0.1, and then I want 0.05, and then I want 0.01. Well, that's annoying as snot. Do you agree? So I don't want to do it that way. I'm going to think of each of these durations as maybe maybe we call it h. All right? And do we all agree this ends up at 2 plus h?
Yep.
But I tell you what, I don't even want to do that because the 2 is nice, but I'd rather be completely general at this point and get good practice. So instead of starting at 2, what letter could I start at?
A.
A, and I could go to a plus h. And this could be, instead of calling this y, could we call this f of t?
Yeah, I think we can do that.
And then we could call this f of a, and we could call this point what?
F of A plus H.
F of a plus h. Huh.
Yeah,
And if I'm doing a secant line, it's rise over run, and this should seem familiar.
Why is this in everything?
Why is this in everything? Because it's calculus. Everybody. And there's good reason to do it this way. Let's be clear about this right now. I'm going to say it nice and clearly. Is that this is the secant line, right? If I want to make it a tangent line, I just have to write this as a limit with h going to 0. But they want secants for a. Do you guys agree? So here I go. All right? I am going to remember this. I'm going to group this graph. Do I have to have the graph? No. Does it help me understand? Yeah.
Dang it.
All right, and I'm going to move this over here. And everybody, I'm going to plug in a plus h into this function right here. And I'm going to do the first one in green. So I get 40 times a plus h minus 16 times a plus h squared minus, and I'm going to do this one in red. I just plug in a. You guys agree it's 40a minus 16a squared all over h. All right, I got some work. Got to do a little work. You got a little binomial, a little plug and chug. All right, I'm pretty good at this. I also realize what at this point?
Everything that doesn't have an H
is going to cancel. If it doesn't, I've made a math mistake. And I'm going to distribute this negative 16 secondary. I'm going to distribute this negative 48 plus 16a squared all over h. we're learning, I'm going to write it out. Because we're learning, I probably would cheat if this was not new to us. And because of the dead spot, I'm going to remove these off, okay? Yeah, and one of the things you're going to learn is that I have a lot easier time than you guys, because when I overwrite, I can move stuff around and stretch. All right, woo!
That was intense.
Yes. Because what's the run over here? The run is h, okay? And the difference here, the rise is f of a plus h minus f of a. And we're looking for the secant line. Rise over run. All right. And we've done all this great work. Here we go. And now I'm going to start canceling. Let's see, 40a, negative 40a, negative 16a squared, 16a squared. Everything else has a h. Factor the h, cancel the h. I think this comes out to be 40 minus 32a minus 16h. All right, so everybody, we got to think about this. And I got all this great algebra. And you know what? All this great algebra I need to do, and I need to do correctly, and I don't care about. I mean, really. You know what I mean? I'm going to put that over here. That's great. And I'm going to move this back up, because that's my result for the secant line. And if I go to 100%, I can look at all this. In fact, I can go 125%.
Oh, so now you can just plug in the...
Right, so we did all this beautiful algebra, but here it is. The $1 million question is, first of all, it has units. This black expression has units. I think it's feet per second, because time is in seconds in this case, and y was in feet. What is a? A is 2 this time. It's the starting time. What is h? The duration. It's the 0.5. It's not 2.5, because this is 2 and 2.5. H is actually the 0.5. Wow, that did not write it all there, did it? All right? Because, again, I can't stress this enough. This is 2, this is 2.5. It lasted 0.5. That's the H. So every time we have the lasting, think about it. That's these numbers. You guys agree? And what's A this time? A is when it started, which we have as 2. So now I've gotten this down to something simple again, where I can write A is 2, H is 0.5, A is 2, H is 0.1, right? Yeah, now I just got to plug and chug. A is 2, H is 0.05, that's Roman numeral 3, and A is 2, H is 0.01. All right, I'm going to pause the video and just get the results here and write them in. All right, so my graph is really bad because all my velocities are negative. So we should realize that really point A is somewhere about here, and my secant lines are all coming down. Or at the very least, I should say that my f of A plus h point is below my f of A point. Right? My secant lines, the slopes are negative. I don't know where it is on the graph. I don't really particularly care. Here's what I noticed, though. As the duration gets smaller, what happens to the velocity? It gets less and less. And then it asks, hey, find the instantaneous velocity when t is 2. So what do I want h to go to? So I'm sitting in this equation. If I want to do the instantaneous, what's the duration of h? 0. I'm going to do the limit as h goes to 0. And I've done all this beautiful legwork. And I'm going to plug in immediately the 2 for A. And I tell you what, we'll leave it there to show the notation correctly, right? But you plug 0 for h, guys, you get negative 24 feet per second. And here's the difference. And it's tough right now. This is hard work. I'm not trying to make it funny. The difference between a secant line and a tangent line, right? But listen, we have to do the secant line work to do the tangent line right now. All right? So this is tough work. Now, could you write this differently? The answer is yeah, you can write this differently. This is where it ges very tough. And I want to talk about this just for 1 second. So if I go back all the way up to problem 5, bear with me 1 second. I'm going to get right up there and make it very big up top. Instead of saying find the average velocity for the time period beginning when t equals 2 and lasting for some duration, could I edit this and say find the average velocity for the time period? And could I say from 2 to 2.5? Isn't that the same as Roman numeral 1? Yeah, couldn't I say from 2 to 2.1? Wouldn't that be the same as little 2? Yeah, and guys, this gets really confusing.
So you could just not slip each.
You could. Guys, you could do that. You could plug in 2 into this equation, get an answer for y, then do 2.5, take the difference of those, divide it by 0.5. Yeah, you could do that every time. And if you had to only find one slope, that would be the best way to do it. But we had to find 4, and we cheat and we read B. And the second we read that we need something instantaneous, we're always going to fall in my classroom to this. We're not going to make A2. We're going to do it in terms of f of a plus h minus f of a. Because if we get really good at this, gentlemen and ladies, man, when we start doing derivatives, we're going to fly. All right? Again, throwing a ball into the air.